Welcome to Auto Fix Pro. Today we dive into the fascinating world of automatic transmissions. Have you ever wondered how a torque converter automatic transmission works in a car? In this video, we will take a closer look at the structure and function of an automatic transmission. This video explains the Planetary gearbox. We will find out which components are installed in the Planetary gearbox. We will also explain which components work together in first gear. So buckle up and let's dive into the technology together. Don't forget to press the like button and subscribe to my channel so you don't miss any exciting insights into the world of automotive technology. Let's go. Do you have any special requests? Maybe I can make a video about it. Also take a look at autofixpro.com. There are already some solved car problems here. Have you already solved a problem? Register there and write it in, no costs. I would be delighted. Let's build together a big database for car mechanics to solve some problems fast and easy. A note, for training purposes, the retaining rings have been provided with holes so that they can be safely removed from the aluminum pots. Here you can see the gearbox 8 HP from ZF. The torque converter, oil pan, mechatronics, and the flange for the cardan shaft at the gearbox output have already been removed. Here you can see the connection shaft for the torque converter, the place for the mechatronic and oil pan, and the removed flange. The screws that secure the oil supply in the gearbox are already unscrewed. The oil supply can then be pulled out. The part is a little heavy. The oil pump is located in the oil supply. The oil pump is driven by the converter's pump wheel via the rear gear ring. The pump wheel always rotates at engine speed. The oil pump is designed as a double-cell vane pump that is driven by a chain. The advantages lie in the small diameter of the pump and optimized flow characteristics. The system pressure of the pump is 80 to 255 psi. If you turn the oil supply over, you can already see the first component that ensures that the power can be transmitted in the gearbox. After I have removed the circlip, the component can be pulled out. The circlip can be seen here. This component can now be pulled out. The component is referred to as brake A in this gearbox. Other manufacturers also refer to it as a clutch. When I pull it out, you can see which components it consists of. I will now explain why the component is called a brake. The outer plates are made of steel. These outer plates are secured against rotation in the oil supply housing by a toothing. As the oil supply is firmly bolted to the gearbox housing, the outer plate can never rotate. The brake consists of several outer plates and inner plates in between, which are connected to the inner plate carrier via a toothing. When the brake is applied by the mechatronic, i.e. closed, the inner discs are held in place by the outer discs. This holds the inner disc carrier in place. That is why it is called a brake. The inner disc carrier has a toothing. The sun gear 1 and 2 sit on it. More details later. I will show the components on a drawing for comparison. Here is the oil supply again. This can be seen on the drawing in blue as number 12. On the left in brown is the torque converter. Here again, brake A with inner disc carrier. Brake A is marked as number 1. The picture shows the darker inner plates and the lighter outer plates. We then take care of the other components that are still in the gearbox housing. To protect your back, you should use a lifting device for the next step. The so-called tower, which is removed next, has already been pulled up a little. I will now gradually dismantle the components from this tower. This tower contains 4 planetary gear sets, the transmission input shaft, 3 clutches in brake B, which can already be seen at the top of the tower. The gearbox housing is now completely empty, except for the parking lock lever, which can be seen at the very back of the housing. At the very top is brake B. The steel plates with the teeth facing outwards are the outer plates, as with brake A. The system always remains the same. These outer plates are fixed in the gearbox housing by a toothing. This means that the outer plates can never rotate. Brake B can be removed from the inner disc carrier without any problems. The inner and outer plates of brake B are located here. The inner disc carrier can then be removed. You can then see more. If you turn the part over, you can see the first component of the first planetary gear set, the ring gear number 1. Here you can see ring gear 1 with the toothing facing inwards. The planetary gears are connected to this toothing. The inner plates sit on the inner plate carrier, so when brake B is applied by the mechatronics via oil pressure, the inner disc carrier and therefore ring gear 1 are held in place. The only task of brake B is to hold the ring gear 1 in place if necessary. Here is the position of the two components in the drawing. In the drawing, ring gear 1 is number 3, orange color, and brake B is number 2. In the drawing, the inner discs are dark and the outer discs can be recognized as light bars. Same coloring as for brake A. After the ring gear 1 has been removed, you can see the planetary gear carrier 1 with the corresponding planetary gears. Normally, the circlip opposite the joint is levered out with a screwdriver. This requires a special tool that is placed over the ring so that it is not damaged. But I don't have this. For this reason, we drilled 2 holes in this retaining ring to make it easier to remove, as otherwise the aluminum pot could break. Here you can see the place where the ring is normally levered out. Here you can see the 2 drilled holes. When removing the retaining ring, you have to hold the pot firmly, otherwise it will slide down. Otherwise it could be damaged or perhaps injure the hand underneath. Here I hold the pot firmly and let it slide down slowly. It is referred to as a large pot. Carefully slide the pot downwards. This will reveal another pot, the so-called small aluminum pot. Sorry, now I have a somewhat wild camera guide. Then the planetary gear carrier 1, which was attached to the large pot via a toothing, can be pulled off upwards. In the drawing, the planetary gear carrier can be seen as number 13. The light gray is the axle on which the planetary gears sit. These can be seen in a slightly darker orange. Now you can see the sun gear 1. A few minutes ago, I mentioned that I would explain the inner disc carrier of brake A in more detail later. Now is the time. The sun gear sits loosely on the gearbox input shaft. A toothing can be seen on the inside. The external toothing of the shaft of the inner disc carrier of brake A is connected to this internal toothing of sun gear 1. It is not yet clearly visible here, but will become clearer later. The sun wheel 1 can be pulled out. You can now see that another sun gear 2, is directly connected. You can then see how I attach sun wheel 1 and 2 with the internal gearing to the external gearing of the shaft of the inner disc carrier of brake A. If brake A is activated by the mechatronics, it holds the inner plates and thus the inner plate carrier of brake A, as already mentioned a few minutes ago. As the inner disc carrier of brake A is positively connected to sun wheel 1 and 2 via the toothing, sun wheel 1 and 2 are held in place. The sole task of brake A is therefore to hold sun wheel 1 and 2 in place if necessary. In the drawing, sun gear 1, number 14, and sun gear 2, number 15 in orange. The flange of the inner disc carrier can also be seen in orange. To repeat, sun gear 1 can be recognized in the drawing as number 14 and sun gear 2 as number 15. Also marked is the inner disc carrier, which is transferred to the flange via a plate. The drawing is not completely identical to the gearbox I am using, as there are slightly different versions. I hope my explanations are understandable and you are still watching. It's a long way to get the power from the engine to the wheels. I have now pulled out the gearbox input shaft. Directly connected is the planetary gear carrier 2. The planetary gear carrier is firmly connected to the shaft. At the end of the input shaft, you can see, somewhat poorly, a toothing. The turbine wheel of the converter sits on this. When the turbine wheel of the converter rotates, the gearbox input shaft and the planetary gear carrier 2, which is firmly connected to the shaft, rotate. In the drawing, the Planetary Gear Carrier 2 can be recognized as number 16 and the gearbox input shaft in green as no more than 21. The connection between the input shaft and the Planetary Gear Carrier can be seen in the gearbox diagram. To repeat, if the gearbox input shaft, which is driven by the turbine wheel of the torque converter, rotates, the Planetary Gear Carrier 2 also rotates. After the input shaft with the Planetary Gear Carrier 2 has been pulled out, the ring gear 2 can be seen. It can actually be pulled out easily, it is only plugged in. However, as I am holding the camera with one hand, it is slightly tilted. Unfortunately, I can't afford a cameraman, not yet, ha 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 ha. After I've finally managed it, you can see the ring gear. Inside, you can see a toothing. From this toothing, there is a connection to coupling E, which I will show later. If I turn the ring gear 2 over, you can see the first component of the third planetary gear set. This is the Sun Gear 3, which is firmly connected to ring gear 2. When ring gear 2 rotates, Sun Gear 3 also rotates. In the drawing, ring gear 2, orange number 4, and Sun Gear 3, green number 20. If you look at this again in the gearbox diagram, you can see the fixed connection from ring gear 2 on the outside via the black connecting line to Sun Gear 3 on the inside. You can also see the connection to clutch E. Finally, the position of ring gear 2 and Sun Gear 3 in the diagram. Now we continue with another retaining ring. Holes have also been drilled in this for easier removal. This sits in the small pot. Here you can see the large pot again at the bottom and the small pot at the top. Once again, I will explain that a steel ring is normally placed over the edge of the aluminum pot so that it is not damaged when the retaining ring is levered out from the joint. The toothing of clutch E can be seen in the middle. As I said earlier, this is in connection with ring gear 2 and Sun Gear 3, which I pulled out in the last step. After removing the retaining ring, Planetary Gear Carrier 3 can be removed. Once removed, the planetary gears can be seen. This planetary gear carrier sits in the small pot via a toothing and is firmly connected to it. You can also briefly see the ring gear 3, which is still in the pot. If the Planetary Gear Carrier 3 rotates, the small pot also rotates and vice versa. Here you can see the Planetary Gear Carrier 3 again in the drawing with the number 19 in blue. Let's come back to the gearbox diagram. Here in the diagram, I'm pointing to the Planetary Gear Carrier 3, which is connected to the clutch D via the small pot. We'll see exactly how later. This connection is shown as a black line in the diagram. We will soon be able to see the connection between the clutch D and the pot once we have removed a few more components. Now you can see the ring gear 3. To further disassemble the gearbox, we now pull out another steel pot with contents. To be able to remove the contents, you have to remove another retaining ring. As the pot is made of steel, there is no need to worry about damaging it. But first we have to pull out the steel pot with its contents in order to be able to carry out the rest of the work. As already mentioned, I now have to remove the retaining ring. Holes would have to be drilled here, as the circlip can be levered out without the risk of damaging the steel pot. To make removal easier, as this is a gearbox for training, I drilled holes anyway. Now the circlip is removed. The first thing I try is to pull out the clutch E. That's not right, of course. It is still attached with another retaining ring. Then I pick up the correct component. The ring gear 3 can now be removed. So here is the ring gear 3, which can be seen in the drawing as number 5 in blue. You can also see the connection to the inner dark blue line, which represents the steel pot, also shown here in the gearbox diagram. Now we have completely dismantled the first 3 planetary gear sets. The 4th planetary gear set and 3 clutches are still missing. If you look into the steel pot again, you can see the first clutch, which I am about to remove. To be seen here now the Planetary Gear Carrier 4 with planetary gears. Also to be seen the parking barrier wheel. If you look into the large pot now, you can see the ring gear 4 at the bottom. When I pull the large pot back up to its original position, You can guess that this ring gear is running on the planetary gears of the ring gear 4. For the last planetary gear set, i.e. planetary gear set 4, we are still missing the corresponding sun gear. To do this, I pull the steel pot upwards. You can now see the sun wheel 4, which is firmly connected to the steel pot. This would now complete all 4 planetary gear sets. Now 3 couplings are still missing. The order of the couplings from front to back is E, C, D. First of all, I will dare to remove the coupling E. To do this, another retaining ring must be removed from the steel pot. Since this retaining ring is easy to access, I have dispensed with the procedures shown so far and have not drilled any holes. Retaining ring has been removed and the clutch can be easily pulled out upwards. The outer slats, which are fixed in the steel pot via a tooth, are recognizable. Here is the removed coupling E. In the drawing, clutch E is number 6. So the first clutch from the left. I'll explain the difference to a brake in a moment. If you look at the picture a little closer, you can see the 3 pots. The outer blue line is the large pot. On the left edge of this line, you can see a green line. This belongs to the Planetary Gear Carrier 1, which I removed pretty much at the beginning. The slightly lighter blue line, the small pot with the connection to the Planetary Gear Carrier 3, and the slightly thicker dark blue line, the steel pot in which the clutch E and clutch C sit. You can also see the connection of the outer plates of the coupling E and C to the steel pot. The last component is the coupling C in the steel pot. I will now pull the clutch C out of the steel pot. Again, a bit difficult to remove with one hand, as the outer slats are a bit tilted. Again, the brown outer slats are recognizable. The difference to the brake comes from the fact that a brake holds a component of the planetary gear sets in place, whereas the clutch connects 2 or more components with each other. Here the removed clutch C in the picture, the number 7. And here is also the sun wheel 4. In the picture, the number 11 with a firmly connected steel pot, which is now empty. If you look at the gearbox diagram, you can see that the clutch C can connect the gearbox input shaft to the sun gear. Here I show again the connection between sun gear 4 and the drive shaft via the clutch C in the gearbox diagram. What was just shown in the gearbox diagram can now be seen here in the original. There is a toothing on the transmission input shaft. On this tooth sits the coupling C with the inner plate carrier, which is not visible here. So when the transmission input shaft rotates, the inner plates of the clutch C rotate. If the coupling C is closed via the mechatronics, the outer plates rotate with it. Now I will show how the power is transmitted further. To do this, I now go to the steel pot with a permanently connected sun wheel 4. The outer slats sit in the steel pot. So then the steel pot rotates and with it the firmly connected sun gear 4 with the clutch C closed. Here you can see how the outer plates of the clutch C engage in the pot. The brown outer slats are located in the recesses of the steel pot. So if clutch C is closed, the outer slats and thus the steel pot and the sun wheel 4 rotate with it. Here again the steel pot with sun wheel 4. Now I would like to show the power curve in first gear on this transmission. Let's start with the transmission scheme. The matrix shows which shift elements are controlled in first gear. That means closed. So these are brake A, brake B, and clutch C. Brake A, as shown in minute 8 in this video, holds sun gear 1 and sun gear 2. Brake B, as shown in minute 5, holds the ring gear 1 in place. As a result, the planetary gear carrier 1 is also firm. Here you can see the 3 components of the first planetary gear set: the ring gear, the double sun gear, and the planetary gear carrier with planetary gears. I am now assembling this planetary gear set. Planetary gear carrier in the ring gear and the sun gear on top of that. Here I now show what happens if the ring gear is fixed and the sun gear would turn. However, the sun gear 1 does not rotate, but is held in place by the brake A. This means that the planetary gear carrier no longer rotates either. As already seen, this planetary gear carrier 1 sits with the toothing in the large pot. So if I hold my planetary gear carrier 1, I also hold the large pot and thus the ring gear 4. In first gear, clutch C is also closed at the same time. The clutch C, as seen earlier, connects the transmission input shaft to the Sun Gear 4 via inner and outer plates via the steel pot. I'm now trying to show what happens when I hold the ring gear 4 and turn the Sun Gear 4. Remember that the ring gear 4 is also fixed via the planetary gear carrier 1, which is held in place by ring gear 1 and Sun Gear 1. Unfortunately, I have some problems now to show it in such a way that you can see something. Okay, I think it's hard to see that way. Let me try something else. I'm going to turn the big pot over now. Usually it's the other way around. But the effect and the function for the first course is also to be shown around. So I can fix the large pot and thus the ring gear 4 and can turn the Sun Gear 4 at the same time. I have attached a marking to the outside of the planetary gear carrier 4. Planetary gear carrier 4 is the output to the cardan shaft, i.e. transmission output. Inside, I made a mark on the pot, which means the Sun Wheel 4. I now start to turn my Sun Wheel 4. The Sun Gear 4 rotates with transmission input speed via the closed clutch C. Now I count how often I have to turn the Sun Gear so that the output, this means the planetary gear carrier, rotates once. So I can find out the ratio of the first gear. I start shooting. I turn the Sun Wheel 4 once, twice, 3 times, 4 times, a total of 4.7 times. Then my planetary gear carrier 4 turned once. This means that the first gear has a ratio of 4.7 to 1. Here, the marking on the planetary gear carrier has arrived back at the original place. The mark on the Sun Wheel shows a little less than 3/4 of a turn after 4 complete unrotations, so about 4.7 times. This corresponds to the ratio on the documents in the first gear. Here you can see once again the large pot with the ring gear 4 at the end of the large pot. Now I show the components of the planetary gear set 4 in the drawing. In the drawing, the large pot, the number 17 in blue color as mentioned before, and the ring gear 4 in blue color, the number 9. Not quite right in the drawing, the arrow should end a little higher up. For the ring gear 4, please excuse me that the arrow slipped a bit in the drawing. I point to the exact spot with the screwdriver. To be seen the planetary gear carrier 4. When I turn it, my shaft, to which the flange to the cardan shaft is normally attached, rotates with it. Also still to be seen is the parking barrier wheel. This is where the jack or lever engages, which you saw after pulling the turret out of the gearbox housing at the very back of the housing. You can see the mechanics for the parking barrier from below. So when I move the mechanics at the bottom, you can see how the lever of the parking lock moves. The parking lock is mandatory because there is no power connection between the wheels and the engine when the engine is stationary, because there is no oil pressure and the clutches and brakes are open. On the tables, you can see all the components that have been removed again. The components are not laid out in a straight order. If you really disassemble and repair a gearbox, you should proceed very neatly and structured. Otherwise, it may be difficult to reinstall all components correctly without much stress. Since I have already disassembled and assembled the gearbox several times, this is no problem now. Cleanliness is also extremely important for the automatic transmission. The smallest particles can interfere with the control system and lead to failure. Therefore, under no circumstances should you work in a place with increased dirt load. On the right, you can see the oil supply. Below the brake B, on the left, the ring gear 2 and sun gear 3, and above the planetary gear carrier 3. Below left the sun gear 1 and sun gear 2, above the planetary gear carrier 1 and above the ring gear 3. Please stay tuned, I forgot something. Now I just noticed that I withheld a component from you. The clutch D is still missing. This is located at the back of the planetary gear carrier 4. When I pull out the small pot, you can see the clutch D. The clutch D could now be removed, the retaining ring loosened and removed. But I'm not going to do that now. The outer plates of the clutch D are located in the steel pot. You can see the interlocking of the inner plates. If the clutch D, it connects the small pot with the planetary gear carrier via the toothing, which is at the bottom of the small pot. 4 of the inner plates are connected to the toothing of the small pot. That's it so far from the mechanical inner workings of the 8 HP from ZF. I hope you have understood something. Thank you for watching. Thank you very much for taking the time to watch the video. The video does not constitute a repair manual. Suitable manufacturer's documents must be used for the repair. Repairs can only be carried out by trained specialists. The video did not deal with repair regulations, but only with the function and the connections of the power flow in first gear. I am happy about constructive and good criticism to be able to do things better in the next video. I am happy about likes and followers. I would also be very happy if one or the other would contribute something to autofixpro.com. Thank you very much.